DNA Internet, the end of computers? Welcome back. I am Adeline Atlas, 11 times published author, and this is the Quantum Humans series. For over 70 years, we've used silicon-based machines to compute, store, and transmit information. But silicon has limits. It's rigid. It's fragile. And we're nearing the end of Moore's Law, the exponential growth curve that drove the tech industry since the 1960s. Now, researchers around the world are asking a radical question. What if the next internet isn't built on chips, but on cells? In this video, we explore the idea of the DNA Internet, a biological network powered by living systems, where storage, processing, and communication happen inside molecules, not machines. Let's start with the foundation, DNA computing. DNA, as we've already seen in previous videos, is a data storage medium beyond anything silicon can match. 1 gram of DNA can hold 215 million gigabytes of information. But what makes it more than a storage system is its potential for parallel computation. Unlike conventional computers that process tasks sequentially, DNA strands can interact with each other en masse, enabling thousands, millions of operations to occur simultaneously in a test tube. The principle is simple. DNA strands are programmed to act like logic gates. They bind, fold, or deactivate in response to certain sequences. Researchers at Caltech and Harvard have already built basic DNA-based circuits that can solve math problems, detect errors, or even play games. One group successfully created a DNA algorithm that solved a classic maze problem using nothing but molecular reactions. But storage and logic are just the beginning. Now comes biological networking. This is where things start to resemble an internet, not of machines, but of organisms. Cells communicate, they send chemical messages, regulate each other's behavior, and adapt to input. Synthetic biologists are now harnessing that communication to create living networks, ensembles of modified cells that exchange information, compute collaboratively, and respond to external data. For example, E. coli bacteria have been engineered to carry memory units, strands of DNA that act like punch cards. When the bacteria encounter a specific stimulus, a chemical, temperature, light, they record that information by flipping a molecular switch. Now imagine a network of these cells distributed through an environment, constantly sensing, storing, and transmitting data. You have a biological surveillance system with no need for power, wires, or maintenance. Some call this biological Wi-Fi. And while it's still early, the infrastructure is forming. Researchers at MIT have developed methods for bacteria to transmit genetic data wirelessly using exosomes, tiny vesicles that act like biochemical couriers. Others are experimenting with optogenetics, systems that use light to transmit and receive information between cells and hardware interfaces. These technologies suggest that the boundary between biology and electronics is dissolving. The goal? A hybrid internet where data moves fluidly between synthetic cells and digital servers. Now let's talk about scale. One vision is the cellular cloud, a decentralized storage and computing system distributed across living organisms. Imagine embedding DNA data archives into crops, trees, or even the human microbiome. These nodes would be self-replicating, resilient, and biodegradable. In places without internet infrastructure, the biocloud could be grown, harvested, or worn. Access would require only a sequencer and decryption key. Already, companies like Twist Bioscience and Catalog DNA are developing plug-and-play systems that can read and write digital data into DNA, bridging biological and digital networks. The idea of downloading a PDF from a petri dish is no longer theoretical. It's being demoed in biotech labs today. Another component is neural biointegration. Several startups are working on systems that interface directly between DNA memory and the brain. In one prototype, neural activity is recorded into synthetic DNA strands implanted in the skull. These strands change in real time, encoding patterns of thought, emotion, or intention. This may sound like sci-fi, but it's grounded in current neurotechnology. The brain doesn't care where memory is stored, as long as it can retrieve it. That's the big idea behind the DNA Internet, decentralized cognition. Data isn't just stored in a cloud. It's embedded in your body, your cells, your environment. The line between thought and network becomes blurred. With advances in optogenetics and synthetic neuron interfaces, the goal is not just to send commands to cells, but to receive data from them. Your immune system becomes a search engine. Your skin becomes a signal antenna. Your gut flora becomes a storage cluster. But with this transformation comes serious concerns. First, biosecurity. A DNA-based internet can be hacked. In 2017, researchers proved that malware could be encoded into DNA and executed when sequenced by a vulnerable computer. If biological data becomes a core infrastructure layer, new forms of cybercrime emerge, ones that exploit genetic payloads, cellular messages, or neural implants. Second, surveillance. If your cells are connected to a network, who controls the gateway? If your thoughts can be recorded by engineered DNA and transmitted, what's stopping governments or corporations from building backdoors into the human mind? Third, equity. Who owns the infrastructure? DNA cloud services, neural access APIs? Will data stored in your cells be your property or a licensed feature? Fourth, error correction. Unlike computers, cells mutate. DNA sequences degrade, react, or misfire. Ensuring accuracy in biological systems requires redundancy, fail-safes, and constant verification. Without these, data loss could occur invisibly. Despite these risks, momentum is building. The National Science Foundation has earmarked funding for biological computing infrastructure. The EU is exploring DNA data centers as sustainable alternatives to power-hungry silicon servers. And DARPA is openly funding programs that explore biocomputing for tactical field applications. From a technological standpoint, the DNA internet is attractive because it scales naturally. Cells divide, data replicates, networks grow. There's no need to manufacture more chips, just culture more organisms. From a philosophical standpoint, it raises deeper questions. If your environment is intelligent, computing, storing, and processing all the time, what happens to agency? To identity? To choice? Do you become a user of the system or a node inside it? The final implication is this: death of the external computer. If data can live in your blood, be processed in your brain, and transmitted through your skin, then laptops, phones, and even VR headsets become obsolete. The body becomes the hardware. The mind becomes the browser. Consciousness becomes both the user and the interface. It's not that computers disappear, it's that they dissolve into life itself. Hi, I am Adeline Atlas, 11 times published author, and SOS, School of Soul has a brand new series, the AI and Future Technology series. Look, you know the world is changing, and no, it's not going back to normal. Normal is over, and what's coming next is beyond anything we were prepared for. The School of Soul, AI and Future Technology series includes 319 videos on 1. The Download Society, How Data Has Replaced Destiny. 2. Predictive Future. Your next moves aren't random, they're forecasted. 3. Social Credit Systems. The behavioral economy now governs access. 4. Hive Mind. Synthetic telepathy and collective algorithmic control. 5. Nanobots inside you. Medical, military, and programmable intrusions. 6. Grief Tech. AI-fueled digital resurrection and simulated comfort. 7. Uploading your mind, consciousness transfer, and data-based identity. 8. Deep fakes plus AI clones. The replication of reality and identity theft. 9. Quantum humans. The merger of biology with quantum systems. 10. Digital afterlife, where your data goes when you die. 11. Resurrection science, reviving life through synthetic methods. 12. Immortal science, the end of death as we know it. 13. Longevity science, gene editing, anti-aging, and bio-upgrades. 14. Designer babies, engineered perfection before birth. 15. Artificial wombs, birth decoupled from the female body. 16. 3D printing, printing organs, limbs, and even humans. 17. The humanoid era, the rise of synthetic beings among us. 18. Legacy humans, the slow phase-out of unmodified analog people. 19. Smart cities, algorithmic environments that watch and decide. 20. Cloud-based societies, citizenship without borders or bodies. 21. Hackable humans, emotion, memory, and behavior under code. 22. Biometric scanning, your body is your password and your prison. 23. Sex tech, intimacy reprogrammed by machines. 24. Extinction of gender, fluidity, deletion, and design of identity. Every topic is fully explored with real-world technologies, patents, case studies, ethical analysis, and future forecasts. These aren't someday discussions. This is already happening. Join the SOS School of Soul Vault to overstand the future before it's implemented on you.